All right, welcome everyone. So today we're going to be talking about Project Tardigrade, which is a project that has been building on top of the Trino project, and it particularly is focused on making ETL a lot more accessible for a whole bunch of folks that have traditionally had struggles scaling Trino to the level that it needed to be. At a cost-effective measure, I guess, you could always just inevitably scale. Project Tardigrade allows you to do that with a little bit of bumpers, just to make sure that as you're scaling up your query, if you essentially run out of resources, your queries won't start failing. And particularly, we do this through some call it fault tolerance. Other times, we just we basically just kind of summarize it as failure recovery. And essentially, this blog here is going to go into a lot of the details about how the architecture is done that around for Trino, and how we remain being a fast query engine that still is able to support this kind of fault tolerance or failure recovery mechanism. So we've done various tests using TPCH, TPCDS, and we wanted to open this up to the general public now to start having you all do your tests. So here I am today kind of talking about how do we actually set this up. The blog does go into a fair amount of detail here, but we wanted to actually have a valid set of steps. So so within this blog, we've nested this repository, and it's called the Trino Getting Started repository, but which has a lot of other activities or projects that you can do to basically trial Trino. But this is the first time we've really done anything that is of scale. So we're going to be running it on Kubernetes, and particularly running it on Amazon's EKS service to make running things on Kubernetes is not necessarily the thing that everybody's equipped to do or running to do. So, it's much easier to actually run this on a cloud infrastructure. And there's a lot of tools that make it very easy for you. So let's go through some of these tools. Particularly, there's the AWS CLI. That's going to be how we manage our infrastructure. So we have to set up like S3 buckets and a little bit of our the lifecycle rules around some of these buckets, and just general stuff that we do on AWS. There's a very helpful tool called EKS CTL. This is a tool that basically helps you work with the Amazon's Elastic Kubernetes service, and kind of automates a lot of the basically the provisioning of these different services for you, so that it becomes very easy to basically use these or to basically set up these EKS clusters without having to, I guess, kind of do a lot of the manual work that goes into it. Of course, kubectl is one of these interfaces that we'll need to kind of interface with the Kubernetes cluster once it's up and running. And Helm is a nice basically like packaging around Kubernetes. And so Trino, for instance, has a Helm. It's called a Helm chart, and this has a lot of the configuration around Trino and what you'll be kind of generalizing the configuration that you'll be pushing out to all of these Kubernetes clusters, and essentially a packaging. So you want to make sure you want to have all these done. The main button here is kind of like the how to install. So you'll be able to open up and read through a lot of those tutorials there if they're not installed already. If you want to verify if they are already installed, let's go ahead. I will clear out a couple of my windows, make sure that these are all clear from the time before. All right, now let's go back here and let's just do a quick check on, whoops. My goodness. There we go. Let's do that. And then we'll run AWS version. So let's do that. Okay, so that gives us something. We also want to do kubectl version. What else do we got? EKS CTL version. And we finally have the Helm version. So these might be a little bit outdated compared to what you can get by the time you are watching this recording, but this is essentially saying that I have all of the required installations. Great. So now that we have that, the next step is to go to your AWS console. So we're going to try to minimize having to do things in the console, as things can change in terms of the console, and stick to the CLI because things are pretty consistent there. The main area where you do need to go into the console is going to be to create the user that has all the correct permissions for us to do everything from the console in the first place. So let's go to our IAM management console. So actually, let's start out even better. If you are coming from not an AWS background, I'm not going to try to assume that you are, right? So they have a nice little search bar here, and you can just click IAM. And IAM is basically a place to manage all of your security, your user roles, and things like that. I have various set of users that I've created before. We're going to create a new one today. We'll call it the tardigrade user. Tardigrade user, and we're going to make the access key programmatic. Because again, we want an access key ID and a secret access key. The other one is more if you're wanting to do things in the console. So we want a programmatic access key. So this is going to be for tardigrade. So let's go to the permissions. And so if we go back to GitHub, this actually has a list of all the permissions groups that we need. So there's various small level permissions, and Amazon AWS actually manages a lot of these for us. There is one that we'll have to make custom for our EKS access that's needed, and we'll go ahead and program that in ourselves. But basically, you'll go into through this list and start searching for these things. So you'll basically go, okay, we need EC2 full access. So let's go ahead and go to the attach existing policies. So these are going to be looking up in the directory of Amazon managed policies. Oops. And get the full access. So that's one. The for full access for EC2. Now we need full access for CloudFormation. Okay. And now we'll need the IAM full access. I'm actually not full. I haven't eaten anything recently. And after that, we'll go to S3 full access. This is going to be the one that we'll need for direct, accessing S3, but our spool and our data that we're going to be writing there from the Trino perspective. So, and then finally, from the AWS managed ones, we'll also need Glue. Glue is the metadata manager for all of this, and so we'll definitely need to be able to access and manage things within Glue. And so finally, if you get to this last one, you might be like, oh, well, let me check out and see if I can find the EKS all access, and nothing comes up. So this is actually one that we'll have to create ourselves. So you'll see this create policy button. And luckily, we have all this pasted here. Now, this comes from, by the way, the IAM policies required by EKS CTL. Again, they run a lot of cool things in the background, but you need to make sure you have permissions for all of them. And EKS is one of the big ones. So let's go ahead. We're here. They have this visual editor to build your own, but we're going to basically just copy and paste the JSON that defines this. And I am just doing a new keystroke or a new keyboard, so occasionally you might see that I'm pasting this thing incorrectly. One of the big things, though, with this policy maker is that we have this account ID that we need to fill out. And so where do we find that account ID? You'll have this little question mark sitting up here. And if you right click and open a new tab with the support center, your account number will be basically just sitting right here. That's a very easy way from the console to go and get it. And so we'll want to make sure that we update that right here. Okay. And did I just... Yeah, I did get that. Let's go do it this way. Make sure I don't go killing any colons. So let me put next tag and let me go ahead and move to the next. Okay, so now we have created this. We're going to give it the name that we have in the things EKS all access. Could call it full access if we wanted to make it synonymous with the other ones. So now that we've created this, let's go ahead and refresh. And now we should see that EKS all access that we just created. Go to the next. We'll skip the tags. All right. And this is just telling us all the things that we've added, all of these policies that we added for this user. And let's go ahead and create it. So now we have a tardigrade user. Let's see, we're going to get the access key ID. So if we go actually here, now the next step is in our console, we're going to use that AWS console and to basically run AWS commands as the user we just created. We can run this AWS Configure command. It's a convenience command to basically update a local configuration file that you have. And so we'll update, this is basically still has the pre-populated access key that I had from before. We'll go ahead and update that with the one that we just created. And, oops, here, let's get rid of that. And then we're going to show the secret key, of course. And by the way, when you get off of this user page, you'll want to save the secret key somewhere safe, ideally a password manager. And or your notepad if it's a very temporary thing. And then basically you're going to insert that secret key, and now we're going to be running commands from the console, AWS console, as that user. We're going to still stay in the same region. You can have a default region, or you can put none for into this. Now I'm going to keep US East 1 since that's the one that I am working in. But you can put a none, and then we're not going to use any default output format. And that's it for the AWS configure. So great. We now have our AWS configured, and now we want to go ahead and start creating S3 buckets. So good news is that you really don't need to do too much more in the console. From here, you can pretty much just do all of it from the CLI. So the first thing we'll want to do is create these buckets. So I recommend, and this is just a little command that you'll have here to create a Uuid using Python. Most Linux most computers really just come with it these days. If that isn't there, you would have to install it real fast just to get this function for the Uuid, or you can even generate one online very easily. So this will make basically a unique ID that is going to be appended to this prefix that we'll create called tardigrade spool and tardigrade data. So these are two buckets you're going to want to create. And the reason why we need this Uuid is because S3 buckets are they share a lot of they share basically the entire namespace with everything else. So you're going to want to make sure that the name that you come up with is unique, assuming that anybody in any other account that is within the standard AWS region is going to basically share the same names with you. So you have to make sure that it's a unique ID. So you can just come up with something and see if it works, or I highly recommend this UUID method. So let's go ahead and do this command. This is a MB, which is make bucket. And we're going to call it tardigrade spool. This is for, of course, the spooling, which is saving the intermediary state of the data. And as Trino chugs along, it saves basically intermediate state to recover in case of a failure. And then there's also going to be the data bucket. That bucket is going to be holding, obviously, the actual data that we're writing. And so spool generally should be filling up and removing and filling up and removing as the operations happen. Data is going to be the persistent data that you're saving. And then there's going to be one extra command that we want to run, which is this put bucket lifecycle configuration. You'll notice instead of the S3, we're using S3 API because this one is a very specialized command that has to interface with the API. And so we're going to only do this on the spool bucket. And we're going to use the spool lifecycle rules that come inside of the GitHub repo. So again, making sure that you're in the same directory of the spool lifecycles rules inside of the Trino getting started repo. Go ahead and paste that command and we'll run it. And what this did, if we go, I said we weren't going to do too much in the console here, in the web console, but it is good to just verify things real fast. And so you can go and see, this was actually the two that we just made just now. The spool is the one where we just added a lifecycle rule. And so this lifecycle rule is just called expire. If we want to look into it, it basically just has the thing that as soon as 1 day passes where an object has not become touched or messed with, then it automatically gets deleted. And that's just to make sure that if there's anything that does get left over in the spool, it doesn't persist and start taking up extra space in your data. So, inside of your spool bucket. Great. So that is a good chunk of it. The next bit is that we're actually going to be creating a values YAML. So this values YAML is actually going to be the driver into our Helm chart that will create the configuration files that go out and tell Kubernetes essentially what to pull up. And what images to pull and all this cool stuff, right? So let's clear this out. And the next thing that we're going to do is we'll see in here that we have that values template. So let's go ahead and copy values template into something called values.yaml. And so now we can vim into values.yaml. And we see there's a couple of these like little placeholders that we put in there. So for instance, Trino version, we want to get the latest version of Trino. So let's go ahead and add, at the current time, it's 379. It might be something else by the time you are watching this. Number of workers, you can technically do more. We would at least minimally say do 5 workers. And what that's going to say is that we're going to have one coordinator node that is going to essentially be the interface between you and the actual queries being executed. And the workers are the ones that are actually executing those queries. So you want to have 5 of those. So now for the base directory, we want to have that. This is in the base directory of the Exchange Manager. We want to get that here, and actually let me get out of Vim here for a second. We'll want to do an echo, and actually I'll add these commands to the GitHub repo. We want to do echo, and then we'll add this. Echo, and then we'll do the same for for data. And so now we have our spool, and actually I'll just copy this and I'll change data when we are updating the values YAML myself. So we'll go in and where did I just missed it? Base directory. We'll go in here and then we'll add that spool directory. So that's adding the spool bucket. And then we'll go down here. And now we need to also access the region. So we know the region is US East 1. And then the access key. Here, actually, let me go ahead and go down here all the way to the bottom. So this is where we're actually going to store our bucket, our data bucket. And this one was the spool. But again, we have the same UUID, so all we have to change in here now is going to be data. And then now that's the same. So now we just need to update. We've updated the buckets. We've updated the number of workers. We've updated the Trino version. Now we're going to update the region, last region here, which is US East 1 again. And then we're going to update the access key and secret keys. There's 3 of them. Oh, wait. So actually, we already got off that page. So we have this saved here onto the side. So we're going to do the access keys. And I'm going to quickly copy over that key, put it there. And we'll do this for all the access keys first. Oops. There we go. There, and finally there. And then we have the secret key. I'm going to do that here. And don't worry, these will be gone by the time this recording meets the light of day. All right. So we're making there. Okay, so now we have all of the kind of placeholders here updated. So we have the access key, secret key, the data directory, the spool directory, the regions, and then all the way up here on the top we have the Trino version and the number of workers. That's pretty much what you needed to replace with those values. Okay, so now that we have our values YAML set up, let's go on to the next thing. So we pretty much are ready to start going ahead and creating our EKS cuddle cluster. And so what this step's actually going to do is it's actually going to pull together a list of Amazon EKS resources, essentially pulling these bigger nodes, these M5 8X large nodes. Again, this is the size that is recommended by the Tardigrade team. And so you'll specify the name. You can call it whatever you want, but we'll just say Tardigrade cluster if you want to just copy paste this. Region's going to be still the one that I was using before, is US East. Depending on where you're at, that might change. Node type, this is the one that's recommended. And then number of nodes. So we talked about there are 5 workers, and then we also have a coordinator worker. So the total number of nodes will be 6. So now let's go ahead and actually run this EKSCTL create cluster. Now this does take a little while, so I'm going to pause the video right here, and then I'm going to come back in just a little bit to basically go over, once we get to the end of this this EKS cluster finishing. So I'll see you on the other side here right now. Okay, so welcome back. The EKS cuddle has now finished basically provisioning all of the nodes in the cluster, the node groups, all the internet or the networking and things like that. To basically make sure that we're up and ready and running to have basically the nodes available to us to run Kubernetes containers on them. So now we actually need to deploy Kubernetes applications on there. It's just basically this kind of Kubernetes cluster, not kind of sitting there idly, not doing anything. And so we will give it the essentially the Helm configurations that will develop these different Kubernetes configurations that will ultimately, so the Helm is kind of like the template, and then the Kubernetes configurations that derive from that will actually become what runs, basically the commands that run on these actual individual nodes. So we look at this last thing here, kubectl command should work now, because basically if we do this like kubectl get nodes thing, so let's go ahead and do that. I already did it just a second ago, but you'll see that we actually have real nodes up in EC2 actually that come back. As we see here, actually, I just a second ago was looking at the deployments and forgot. Yeah, we have to actually deploy something. We have not deployed anything yet, and so therefore we need to do that as the next step. So if we go here. We can run the Helm upgrade install. So before we actually run the Helm upgrade, let's go over and run what's called a Helm template. It's basically just going to be replacing the upgrade indicator and or upgrade command to do template instead, and it's going to show us what Helm actually outputs to send to the Kubernetes cluster. And so here, if we see there is this deployment, and there is this so deployment for the coordinator and a deployment for the worker type. So there's different deployments for each type of node. There's a service that actually exposes the port that we're actually going to be running the web server, as well as running actual requests, sending requests to Trino. All goes over the 8080 port, and then we have this config map that actually configures the different sessions on the different properties. So once we have all of those set up, then we can actually run the Helm upgrade install command. So we can go ahead and run that now. And now this is going to basically say, yeah, release does not exist. And so it's going to go ahead and deploy that. And now that it's installed, getting application, and yeah, it looks like it's status deployed. Yep. Okay, so we are good now. So they actually have like the commands that we can run for this. We also have those same commands down here. Now, before we run those though, let's go ahead and do a restart just to make sure that all of the configurations on the nodes did get properly set up. So that's basically going to restart the nodes. And now if we actually do a kubectl get deployments, we should be able to see now we have not all of them. We're still waiting on one of them. The coordinator's up, and then the workers are yet to be up. So let's see if we can wait for the last worker to come up. So now we actually got the Trino worker stable at 5 out of 5 and the coordinator 1 out of 1. And now we can actually go ahead and run the command, this port forward command here, now that we've gotten everything restarted and good. And this is actually going to bring the 8080 cluster port that's been exposed through the service, and forward that, or basically create a tunnel, SSH tunnel, directly to our local laptops. Now that we have that running, we should be able to go here into Trino, the Trino web UI on localhost, and then we don't have any type of authentication set up in this in the setting that we had for the Helm chart. So we'll just log in with any random name. We can be Trino, could be Bob. And so as we see here, we have 5 active workers. And so now basically we get here and we're almost ready to like start actually running some queries now. Let's go ahead and download the what's it called? The executable jar. So if we look at the latest, if we come to the CLI docs here that we linked from here on the instructions, you can actually download the Trino CLI executable jar. So I'm going to go ahead and do that. Let me see, save, gas, and then save it. Okay. And now save it to the desktop. And then I will now, if I run, basically, if one thing I want to do is I want to make sure that I change the mode of access to +X and basically say the Trino CLX 379 executable jar. So if I do slaw Trino, so we now see that this jar is now an executable jar. And we can actually let's just change it from Trino CLI executable jar to Trino. And now we can actually just say Trino and just run that, right? Okay, so now that we have it labeled as Trino, why don't we just open it up and start taking a look around? Just initially. So if we look at the catalogs, so we can do with show catalogs, and this is going to show four catalogs. One's the system that's basically just showing runtime variables on Trino. Then there are two generated data sets for benchmarking, TPCH and TPCDS. These ones are very useful, especially in cases where we're trying to work up at scale, validating a certain use case, a high scale use case, and trying to have like a kind of benchmark that can be run across multiple systems. So we follow the TPC standards, and one being the DS standard and the H standard. And so so we can run those, and that basically generates data. In fact, we can run one really quickly. Let's show schemas in TPCDS, because that's actually the one we're going to be running here in a second. We have inside of each of these, and this is the same in TPCH, I think roughly the same scale factor. So we have SF, and that stands for the scale factor. Tiny is the small one to remember, is like if you want to just play around really fast, tiny is always an easy one to do. And then scale factor 1, obviously as you get to the higher numbers, there are different multiplicative factors of how big the data and the number of rows are in each of these data sets. So if we wanted to just show, a simple table of like, select all from, and I know one of these, in fact, actually, let's just show the tables in here. Show tables in SF, tpcds.sf1. Then we can see a couple of these. So let's look at, we can look at item and do select all from tpcds.sf1. And we'll do customer here, and then limit 10. So this is all just generated data that kind of fulfills, like a customer ID in this particular schema. And so, so what we ultimately want to do, if we go back to showing the catalogs, can I do clear here? No. Yeah, there you go. Show catalogs. So we now can again see that Hive is there. So that Hive config, if we look at what it's pointing to, so we can actually look at, it's pointing to this AWS Glue instance. And if we look at S3, we can actually see that again we remembered we had created this spool and this data. So spool gets used during operations for Project Tardigrade to basically save intermediary results so that it avoids that crash in case a task fails. And then the data is actually where we persist the data again. So that's where that Hive catalog is connected to. So what we want to do is actually go over here, grab the schema. And this is going to basically say, use the Hive catalog, create the schema called SF10, and that's going to be mimicking the scale factor of 10 schema that we had in the TPCDS data. And then we're going to point the location to, again, this. Now, this is actually going to be the incorrect thing. I have to make sure I update this this bucket here and then point it at SF10. So, so let me go ahead and actually put right up until this spot right here. Oh. And then we need to put this S3 bucket here. We'll get the copy. Add that there. And we'll copy the rest of the command. So make sure that you do the same thing, that you're not, and I'll probably just take this out and say it's the data with the Uuid. So we'll, whoops, again, post that in there and create the schema. So what that does is now in Glue, we should be seeing now a schema is equivalent to a database. So let's just refresh that there. So we should see SF10 and then the exact location that it's pointing to. So that is saved now in that side. So now we'll actually run a real query we'll run the Q1 queries. And if you want to do anything other than just Q1, we have the links to the TPCH and TPCDS like queries that are actually run for the benchmark. And these are all saved here in this database. All you have to do, all I did for this was copied this exact query for Q1, and then I just added the hive. So these, essentially these tables, what we need to do for this, actually, I was about to run this incorrectly. So we can actually run this Trino, and we need to run catalog so that we don't have to specify TPCDS, and we don't have to specify the schema to be SF10. So now we can come back in, and now when we run the query here and we say, for instance, from customer total return, it will know that we're talking about that table that exists in the TPCDS SF10 data when we're running in this current Trino session. So now we can, the only thing we have to specify is when we're creating the new table, we're going to say create the table as this, the catalog, the schema that we just created, and then we're going to call it Q1 since it's the first query. And then the rest of these tables can stay as is because, again, they're all under this TPCDS. So let's go ahead and pull that down and run it. Put a semicolon there. So now this query is actually running at full scale. It's going to be doing its thing. And what we actually want to do, we can now use kubectl scale command to actually tear down and make the replicas go from 5 to 4. So it's currently running on 5. Let's go hop on over here into the third console and actually run this kubectl scale and basically make the workers go down to 4. And so, so we should see, well, it finished creating the table before I could finish. Isn't that the case? Okay, so now let's go ahead and is that SF10 wasn't long enough running to get us what we need. We need to go to a bigger schema, so we're adding on one scale factor of from 10 to 100. And let's go ahead and rerun that query. Now, we're going to just store it in SF10 and we'll run it with the next level up. We'll just do Q1_3 for the table name. And then we're going to rerun this same exact query, but now at a different scale. So it's going to take it longer to run. And while we're running it, we'll do the same thing. We'll go down in these, basically the number of replicas that are there. So again, we now see this is running. Let's see. So these are roughly the stages that are getting executed right now, kind of lower level stages. Let's not, even though we have more time now that this thing's going to take a little bit longer, let's not take too long. Let's see, where is it? Go down here. Back to 5 workers. Okay, so replicas 4, boom. We scale it down to 4. And so let's give it a second. Once it goes down to 4 workers, we can go here and look in the stages and see, we can look in these tasks to see like where, if there's anything that is failed. What we should ultimately be waiting for, and it's going to take it a while, there's a couple of these are in pending, but we should expect one of these that are currently running. Let's see, what's running right now total? Let's see. So once we get basically to one of these that are running right now, there's pending. I have to refresh again and see if there's any that are trying to run. Did I wait too long? Okay, this one's planned. And what might be happening now. So essentially, we have some that are in a planned state that are kind of being held off right now, right? And I believe that, essentially one of these tasks of the node that went down is currently holding up the operation. Now, there's a configuration that you can set on default, without any updates, it defaults to 5 minutes. So basically, it's going to take 5 minutes for this to for basically Trino to realize, hey, this task absolutely has failed. And so I think it might be this 5.0.0 task, possibly that we see in a failed state later. So I'm going to pause right now, and then I'll come back in just a second to cover and see if we actually did get that failed state. Okay, so after a long 5-minute wait, this task finally went into a failed state, the one that was kind of impending, and basically a new task, this 5.0.1, which is like kind of the next instance of the task retry, was started, and basically the rest of the query was then able to go and complete all the way until we got to the top. And I don't think there were any other failures as far as I can see. Yeah, it was just mainly that one task that was currently being run by the node that we toppled over. So let's go back to the last bit. So that's basically all you have to do. So even though this is showing, maybe I'll scale this up to 100, but we'll even keep it to SF10 just so you can actually run a query initially, and then run this whenever you're on a higher scale. Okay, so let's talk about teardown now, just to make sure that you're not going to get charged a whole bunch of money for keeping all this infrastructure up. So first things first, let's go ahead and tear down the existing. Here we go. Actually, we're gonna take this down. Let's take down the existing S3 bucket. So that force thing is going to, right here, kill all of the data that we just created. So I'll let that, it's saying that access denied, and I have to delete all objects. Bucket will not be deleted. Oh, that's great. Well, that was in the spool. Huh, why that was not the case? Okay, well, you might have to manually go in then and delete the bucket. Let's go ahead and refresh, see what actually did happen. Yeah, so another option is to go in here through the console and actually force delete this stuff. Let's see if I have any luck doing that same thing with data. Let's try data. Yeah, also failed. I believe that there's probably a... of course, decided I got full access to that. So this might be just one of those weird issues where I need to have a special access, a special permission to delete it. So if not, you can't do it there. Just go ahead and delete this bucket. Confirm deletion. Use the empty bucket. All right, now we'll do permanently delete. We'll go ahead and do that. Okay, and then move back to buckets, and now that one should be, oh, it's not gone. Here. Okay, and close that. And now we should go into data. That is all cleared out. And this one's all cleared out. Okay, so now we should be able to delete. I don't know if you can, yeah, you can't multi-delete for buckets. So actually now we should be able to run those. And surprisingly, we're not able to. So remove bucket failed. Access denied. Still denied. Okay, so either way, whether you do it through the CLI or whether you do it through the console, you can just go through these, manually delete them out. And that way you're not getting charged all the big bucks from Mr. Bezos. And then delete this last one, because I think that was one that I created from a previous one. You should only have 2 to delete though whenever you go do this. All right, and that that took care of that. So I'll look to see about making sure that that permission is correctly updated so that you can actually delete it. And now we just need to run the command delete EKS ETL delete cluster. This does all the magic that the inverse of the magic that happened before. Again, this takes some time, so you're going to have to kind of wait and let it do its thing. What you essentially want to validate at the end of all this are 2 kind of areas. You'll want to definitely go to the EKS service and go to the clusters and go to the tardigrade cluster. And essentially make sure that basically this one doesn't exist. So this tardigrade cluster should just go away. And then after that, go to cloud formation and just make sure that this actually goes away. And finally, with EC2, you'll want to make sure that the instances that you have running specifically to tardigrade clusters, that those ultimately all go away, because those are expensive. Outside of that, that's pretty much all you'll want to verify. And let's see if that is the end of the tutorial. So that is how you we'll go through. I know there's actually a lot of small nuance and detail, but once you actually get used to kind of deploying things onto the cloud, this shouldn't be too hard. I went into a lot of explanations into things that probably a lot of you know already about, but wanted to cover my bases in case somebody's relatively new to the cloud and wanted to get started on using some of these really cool features. And so that's tardigrade feature at scale. What'll be really cool is to see if some of you out there would want to do a full-scale benchmark or try to do a lot of other fun things of like, how can I scale up my queries and see, when I get to like, I don't know, various memory limits, things like that. Really excited to see what you all do with this once we get it out there and in your hands. And then just give us your feedback. Hopefully you can actually find use for this in your, if you're already running a Trino cluster. If you're not, and you're thinking about, breaking into it, Trino has now 2 modes. This mode of tardigrade that kind of makes it very useful for ETL. And then the mode of like kind of regular interactive analytics, that's super fast. Everything Trino is known for. And likewise, with tardigrade, we've had some very good initial benchmarks in terms of things not getting slowed down tremendously when adding this extra overhead. It's really been a great experience so far. So definitely looking forward to hear what you all have to say, and happy querying.